Welcome back to Tansy Academy, and in this particular video we'll be starting chapter 3, and then the first lesson will be database tables. The lesson 1, database tables. This is the core lesson or topic for your SQL training course. So it will be little bit lengthier because it's very important for you to understand the concept of a database table. Whatever you do in your assignments, in your project, everything is around the table. So you need to understand what a table is. So before getting into what a database table is, let's actually try to understand what a data is. So data is information or facts that can be collected and used to understand things. Information in the sense, let's say, we have a student in a university or a school. So what information can you get for a student? You can say this is the student's first name, last name, his date of birth, his age, address, phone number, so and so. Same thing for the client information. You can say this client is from this city, his gender, age, and address, phone number, email. So are facts that can be collected and used to understand things. Facts in the sense like how many products have you sold, what was the revenue for a day. So data is a collection of information gathered by observation, questioning, or measurement. For example, numbers, words, pictures, or even sounds and videos can be data. Okay, so all these are different types of data. People use data to answer questions, solve problems, or learn new things. Okay, so here are a few simple examples of data. Numbers: 25, 40, 100,000. This is nothing but data points. 25, it might be age, or temperature, salary. And then words, even like any word, any English dictionary word is also part of the data. Okay, like happy, blue, Jordan, this is a name, architect, role, married, New York City name, 10th grade. So these are all data points. Pictures: a photo of a tree, drawing of a house, brain image scan is also part of the data. Okay, sounds: the sound of a bell ringing or birds chirping, this is also part of the data. Okay, so I hope it's clear what a data means. We have covered various examples here. So now let's see how data can be represented. So this I think everyone have already seen this in a daily newspaper or in the TV news or in YouTube channels, videos. Especially you see these graphs when they talk about revenue of a company, or in whenever they have election results declared. So you see such bars or circles. So in the first one, this is called a bar graph. Here we are trying to show the sales figure in $1,000 per year. This is the sales figure for 2020. This is the sales figure for 2021. So for 2021, the sales revenue was over $200,000. Same way for 2022, this is the sales figure, and this is sales figure for 2023. See, you can capture the data in any format, and also you can display the data in any format. So this is one of the format that how you are going to use the data and try to understand what it is saying. So this is a funnel. Generally people use this for sales pipeline. They say that I have 210 inquiries, out of which I have given demo of my product to 175 potential customers, and then out of those 175, 130 went into trial phase, and finally 83 purchased my product. Okay, so here we are trying to see the share of a product type in a total sales of a given day, month, or a year. So there are different types of charts. These are the three basic charts that I want to show. So what I'm saying is, first we try to understand what a data is. Even though you cannot define an all, at least you have a sense or your understanding of what a data is. And then we are seeing how a data can be represented. And this is the other way you can represent it. This is a very common way. This is called a tabular data. Okay, it refers to data that is presented in columns and rows. Okay, so now this is rows. Okay, 1, 2, 3, you can have millions of rows. Columns is vertical. It's like a columns of a building, they are vertical, so columns are vertical. So tabular data refers to data that is presented in columns and row, and this is how you will be representing the data in your database using SQL. So this is very important. So tabular data, this is one of the form how we display data, and this is other form. Okay, and then here we have data for top 5 countries by population. Let's see what else we have. This is another example of tabular data. Here we have patient medical data, we have patient ID, age, gender, what is their BPM or blood pressure, sugar, and weight. And then we have top 5 students data from a given school. We have student ID, name, class, their score, and grade. And then here we have sports event performance data, athletic ID, name, sport. So you can have the data is like variety of data. You have already, maybe you might not know that this is a data, this is a tablet data, but you are already using data on day-to-day basis. Okay, here this is banking transaction. If you log into your banking account, you will see something like this. Let's say what is your transaction amount, what is the transaction type, did you try to withdraw, deposit, or do an online purchase, and what was the transaction date. So okay, this is the sample of banking transaction data. Here is a food delivery for orders data. Here we have order ID, and then what's the customer name and which restaurant he ordered a given order, what was the total amount, what is the status of the order, whether it's delivered or pending or cancelled, and when was the order made. So I'm trying to show data from different business domains so that you can understand the concept of data and the tabular data represented in tabular format. These are columns again, like a building, vertical columns. The horizontal rows are horizontal and columns are vertical. Here maybe a few of you have already used Excel spreadsheet. Even in Excel spreadsheet, you represent data in a tabular format. These are the columns and these are the rows. Okay, so here what do we have? Account ID, again this looks like a banking data. Description, amount, debit, credit. So what is the transaction? Is a debit transaction or credit transaction, and what is the status of the transaction? Okay, and then finally this is how the data is stored in your database, and you can query the data using SQL. So for you to understand tabular format was very important, and finally I'm showing you how actually it looks like when you try to query the data from your database. Of course, we will have a good number of assignments in chapter 5, 6, 7, how to create this table, how to insert the data, and how to manipulate and how to delete. We do have assignments, but this is how it looks like in a database table, data stored in a Postgresql database table. Okay, and then this is we can call this like a structured data, because you have fixed number of columns, and then you can have any number of rows. Don't get confused. You can even have 100 million rows, but the columns are kind of fixed in a fixed format tabular data. But here there is something else called semi-structured data. Okay, let's see why it is called semi-structured. Information that has some structure like labels but isn't in rigid tabular format. Okay, so here this is rigid, right? We have 1, 2, 3, 4, 5, 6, 7 columns. That's it. We haven't defined 8th column. So when you are trying to capture data after the columns are defined, you can capture only for these predefined columns. But in semi-structure, let's say here you have country label and population label. You are trying to and rank label, right? You are trying to capture the population of a country and rank them according to population, right? So you can also do this in a tabular format. But here is the example where you can see the flexibility of semi-structured data. Okay, let's say this is the result column. We don't have a result defined here, or we don't have result being used in the top 5 rows. Okay, and then in the third row you can see only class, you don't see score or grade. So this is kind of flexible in terms of columns. You can add on the fly. You don't have to pre-define these labels, or you can call it even as columns when you compare it with tabular format. Okay, so that's why these are called semi-structured. They are a little bit flexible. Semi-structured means these are also structure. You can see the labels here, but you can add new labels to a given row, and you can skip a label. And there is something called unstructured data, information that doesn't have a clear structure or easy to follow format, like pictures, videos, or random text on a Twitter or X platform. So this is called unstructured data. And even though this is unstructured, you can still make do analysis on this. For example, here is the analysis done on this unstructured data. We are trying to pull top 5 words. KIT is used twice, university is used twice. So this is how your Twitter data is actually analyzed in real time to find out what events are going on in a city, or whether there are any weather calamity happening around the world. And then they try to cover and find out in automatic way, like to say, okay, what's going on around the way. And then if they have any triggers to say that I see a lot of posts regarding a bomb threat, or lots of posts regarding an earthquake, and then you go and have a detailed news on that topic. Okay. So now after talking about unstructured, after talking about data, tabular data, chats data, right? This is the data represented in chats, tabular format, and then semi-structured data, and then unstructured data. Now is the time to get introduce ourselves to database table. Okay. A database is like a giant box where we store lots of information. At homes we have boxes where we keep throwing all this stuff in it. So we can compare that giant box to a database. A database to store there can be different databases related to different business domains. In a hospital you have hospital database, in a bank you have banking database. Okay. In a school you have student database. So at the higher level of hierarchy you have a database like a box. Okay. And then at the second level you have the database table. So this is the actual topic that we are going through. A database table is a structured way to organize and store data within a database. Okay. Example, we have a school database. So a table can be about student, because I can collect information for 100 students or 1000 students. So you have to group the student information together into a student table. If you are trying to collect information about teachers, you have to group them into teachers table. Teacher is a table, and then you can have any number of instances or rows of teachers. You can have 50 teachers or 100 teachers. Similar way, if you want to capture attendance, you use attendance table. So you have a database, school database, and within the database you will have different tables. Okay. It's like in a box you throw out the stuffs, but in a database what you do, you organize, you group the similar data into a single entity that is called database table. Okay. And then you cannot say that let someone is trying to pay the fee, you cannot store that amount under student table, because student table is meant to capture student information. No doubt if you have poor design and all, you can store, but it doesn't make any sense, and no one can, even when you try to read it, you'll be getting all mix of data from students and fee payments. So that is not the right way of storing data. So data should be organized within a box. So the way that data is organized is by using a concept called database table. Okay. In a banking database you can have tables for customer, account, cards, transaction, loans, fund transfer. So if a fund transfer is happening, let's say on a given day there are 40 fund transfer happening, so that information is stored in a fund transfer table. It is not stored in transaction or not stored against cards or accounts. Okay. So that is the concept of database table. It is to organize and group similar information together. Okay. This tabular structure allows for efficient data management and retrieval, as each piece of information is systematically organized. And then one more thing, the database table is stored in a tabular format. Okay. So now we have looked at what a database table is, and there are different parts of a table. Okay. At a very high level you have columns, rows, and cells. Let's see what they are. So in this example, the columns are name, age, favorite color, and favorite food. These are called columns. And rows, these are horizontally. We have a row for Alice, we have rows for Bob, and we have a row for Charlie, right? For the row for Charlie, what information do you have? His name is Charlie, his age is 10 years, and his favorite color is green, and Charlie's favorite food is ice cream. So that's how you read a particular row. Okay. And if you look at the row for Bob, his name is Bob, his age is 11. This is a row number 2 for Bob. Okay. Bob's favorite color is blue, and Bob's favorite food is burger. Okay. Cells is like the intersection of row and column. For example, pink Pink is an Alice row under the favorite color column, but this is called a cell. And here burger is a cell for intersection between this row and this column, so burger is a cell. Okay, so there are three parts on a table. You have columns, you have rows, and you have cells, individual cells. So let's look at the database table lifecycle. It starts with a blank grid. Okay, now we don't know what the name is, we don't know how many columns, we don't have the rows, we don't have the data. So it will start from here, and you have to think what I am going to store. So you have to name it. I am going to store student information, or I'm going to store a customer information, or I'm going to store sales information. You have to know before you actually start creating a table. Okay, so you provide the table name and list of the column. Let's say you have decided to store the information of your client, so you can name this table as client, and then you need to have columns. Okay, what you want to store for against your clients? I want to store their first name, last name, phone number, email, their address, whatever. You can store anything. You can store their country, city, religion. It's unlimited, but you won't be capturing every possible thing. You will be capturing what is required for the business. That's what you will be doing. Okay, so now here we have defined this table as country GDP. I am trying to capture the GDP information of countries. So what will be the possible columns here? So I am ranking the country based upon the GDP. So this is the column for GDP, and this is the column for storing population. So first you have to decide what information you're collecting, name a group like table name, and then decide how many columns you want. Okay, and then at later stage you start collecting data. So I have the row number 1, United States, this is GDP, and this is a population in millions. And then I can keep on adding data to the table in form of rows. Row number 2, China, this is GDP and this is population. So you can add even millions of rows to a single table. Okay, it's not that you can add 5 rows, 10 rows, 1,000. No, it's not limited as long as you have enough space on your hard disk. Okay, and then look at this. I have defined only 4 columns, so you can capture data only for 4 columns. So this is structured data, tabular format. Okay, if it was unstructured, then you can capture. See, I'm capturing these 4 columns for last 10 years, and then I'm in 11th year. If it's unstructured JSON data, I can capture some new element that was not captured for last 10 years. But in a tabular format, you have to define the column before you can start capturing. You can define a column after you add 5 rows, and then we add 6th row. You can capture data here for 6th row, a column, new column, but this will be empty for previous rows. That's allowed. And then you can also modify data. Let's see here, the population of Germany is 85 million. You can change it to 110. You have created a table, you have added new rows. Right now I'm trying to modify the data, and then I can also delete the data. Okay, so this is all part of database table lifecycle. Okay, and then data finally, the purpose of there is no fun in storing millions of rows on your computer or database table. There should be some purpose. Okay, so the purpose is you will retrieve the information in some format so that you try to understand your business. Here I'm trying to sum up the GDP of the 5 countries and trying to sum up the population of 5 countries. So, and also I'm going to rank them. Okay, so data retrieval, this is also part of the life cycle. You will see what is the minimum population country in 5, what is the maximum population, what is the sum of population, what is the average population. So you can do n number of things when you're trying to retrieve data. Okay, so let's reiterate. First you have to define what the information you are collecting. Here I'm collecting GDP, then how many columns you need, then you start collecting data, then I can manipulate. It's not required you have to manipulate. You can or you cannot. If required, you can delete the rows, and then finally I am trying to retrieve data in a different format using all the mathematical calculation. So here's a final note on table design. So this course is for a beginners level SQL training course. So when you get your first job, you won't be designing tables, but you need to understand what a table is, what is the concept of designing table. But in reality, you won't design tables unless you are working a startup where there are only 10 IT resources or 10 employees, where you will be forced to design the database tables as a SQL programmer. But mid to high level companies, you won't be designing with the experience of 1 or 2. You should have at least 5 years of database experience before you can start designing. See, some people also start designing after 1 year or 2 years, so it depends on the situation. Okay. In enterprise level, a data architect or a data modeler is responsible for designing database tables. In a smaller to medium sized company, data analysts also have the opportunity to design tables. As part of chapter 3 assignment in this course, you will have the chance to identify and list tables and columns for various software applications. So we will be going through chapter 3, where you will be having a assignment to actually define tables and columns. Okay. In real world applications, banking software can have anywhere from 100 to over 1000 tables. However, for our projects, limiting the number of tables to 10 to 20 is sufficient. So that's what we will go with. With this smaller set of tables, we can ensure coverage of all aspects of SQL programming language. Okay, so I'm going to end here. Let's get into next chapter.